In this video, we're going to discuss the graphs of sine and cosine. Let's start with sine, and the same goes for cosine. This letter A in front of the sine function, this coefficient A, we call this the amplitude. The amplitude will be defined as the absolute value of A. And what the amplitude does is it tells you the maximum and the minimum value of the function. And you'll see it on the graph as a vertical stretch. A vertical stretch, if A is greater than 1, you'll see a vertical shrink. If A is less than 1 but greater than 0, that's when you have a fraction, but it's a positive number. And you will have a reflection across the x-axis when A is less than 0 or a negative number. And I will demonstrate that to you later on. This letter here, letter B, this letter affects the period of the function. Remember that the period stands for the length of the cycle. So this affects the length of the cycle. The length of the basic sine cycle is 2 pi. And also for cosine, the length is 2 pi. Its period is 2 pi. That means you will have one complete cycle in 2 pi. When you have a b here in front other than 1, if b is greater than 1, this will change your period. It will decrease your period. That means that the length of the cycle decreases. When b is less than 1 but greater than 0, a fraction, a positive fraction, this increases your period. That means that the length of the cycle is longer than 2 pi. And when b is less than 0 or a negative value, what we have is a reflection across the y-axis. Okay? Now let's talk about letter C. This C here. Letter C we call the phase shift. And what this number does, if I have bx plus c, my graph will move c units to the left. If I have bx minus c, the graph will move c units to the right. This number does not affect the period. It doesn't affect the amplitude. And I'm missing something here. This should say plus d, and that d will affect or will cause a vertical shift. And what that means is if I have plus d, my graph will move up d units. If I have minus d, my graph moves down d units. Okay, and now let's see, I have a program here in GeoGebra, and I want to show you what that looks like. Here we have the sine function, and notice that here is what the function looks like right now. This is just the basic sine function with a coefficient of 1, which is the amplitude. Notice that 1 is the maximum value, and I have a 1 for b. Remember that b is the length of the cycle. So since it's 1, then this cycle has a length of 2 pi, which is the period for sine. Now I'm going to start moving these values here. Notice a, which is the coefficient here for my sine. If I increase a to more than 1, if I increase a, watch what happens. It starts stretching vertically. You see that? That's what happens when a is larger than 1. You get a vertical stretch. So if a is 4, notice that my maximum value will be 4, and my minimum value will be negative 4. Okay? Now watch what happens when a is less than 1 but greater than 0. That's a fraction. It starts a vertical shrink. Okay? Now when a is 0, then the graph will be 0 because 0 times anything will give you 0. Let's see what happens when a is negative. When a is negative, we said we would have a reflection across the x-axis. You see how the graph flips along the x-axis. This would be a positive a, this would be a negative a. So you have a reflection. Okay, let's bring a back to the value of 1 and alter b. b, we said, would change the period or the length of the cycle. Notice that right now, one cycle, which would be this curve here, stopping at 2 pi, that is one cycle of the sine function. When I alter the value of b, when I have a b that's greater than 1, for example, let's say b is equal to 2. Now one cycle, which is this curve here ending at pi, one cycle now occurs when I reach pi. Before, one cycle would stop at 2 pi, right? Would end at 2 pi. Now, one cycle ends at pi. So we say that we have decreased the period because now the length of this cycle is shorter than what it used to be. If I increase to 4, for example, my period is even shorter. Okay, the length of one cycle now is pi halves. And notice also how many cycles occur from 0 to 2 pi. Let's count. Here's one cycle, 2 cycles, 3 cycles, 4 cycles. So between 0 and 2 pi, I have 4 cycles of the sine function, which coincides with what b equals. b equals 4. Now let's see what happens when b is between 0 and 1. Okay, here's b equal to 1. When b is less than 1, but not negative, just a fraction, watch what happens to the length of the cycle. Here's b equal to 1. At 0.9, already you can see that one cycle is longer than 2 pi. It ends at a value longer than 2 pi. So I will have longer periods. You see that? At 0.5, look how long the cycle is now. Here's one cycle ending at 4 pi. Okay? So between 0 and 1, the b, when it's equal to a number that's a fraction but positive, what it does is it increases the period because the length now is longer. And what happens when it's negative? When it's negative, it's hard to see here because of the form of the graph. But what's really occurring is that I'm having a reflection across the y-axis. Maybe if I use the tangent, you'll see it better. Let's use the tangent just so that you see what happens when b is negative. You can see it more clearly. When it's negative, you see how that flipped across the y-axis. Okay? There you go. It flips across the y-axis. Okay? Let's go back to sine. Now let's alter c. C, we said, was the phase shift, and what that does is it moves the graphs to the right or to the left. So when I have c equal to 1, for example, then I'll have x minus 1 here. When it's minus, it moves the graph to the right. You see? It moves it to the right. When c is negative or plus in my equation, then it moves it to the left. Okay, see how that moves to the left, and see how my c values vary here. That's a phase shift. All that does is moves it to the right or to the left. And my d is the vertical shift. This will move it up or down that many units. If I have d equal to 3 and I was at 1, the maximum value was at 1 originally, I've moved it up 3. Now the maximum value is 4. I can also bring it down. If d is negative 4, for example, and it was at negative 1, then my minimum value now is negative 5. And that's how these variables affect your graph. I hope this gives you a visual concept of what this is. For my next video, we're going to start doing examples on how to graph these functions with the transformations. We're going to do it step by step. So I'll see you in my next video.